And we're live. Hey, folks, welcome to the MongoDB live stream. My name is Michael Lynn. You may recognize me from the MongoDB podcast, available at mongodb.com/podcast, and everywhere you get podcasts. Today is a special day. We're going to go live in a few moments with some special guests. We're going to bring Karen Walney on board, and she's going to talk about a very cool application she wrote. But as folks are piling in, I'd love to know where you're from. I'm on the East Coast of the United States, and I'm interested in finding out who is at the furthest point from my location at the moment. I'm curious where you're all joining the stream from today. Let me know in the chat. MongoDB, Austin, Texas. Awesome. Let me know where you're from. Today is going to be an interactive session. We're going to do a live stream, and we're going to be demonstrating some aspects of software development specific to search. I'm excited about that. If you're interested in search, let me know why. We're going to be talking about soccer, football. And I'm curious about your favorite football team. Who are you rooting for in the WC? Bangladesh, welcome. Poland, welcome. Welcome aboard. All right. We're just about a minute. I'm going to give it another minute before we get things kicked off. Like I said, I'm on the East Coast of the United States. It's about, 50 degrees where I'm at. It's a beautiful day. Where are you at? Where are you joining the stream from? And who is your favorite football team? Who are you rooting for in the World Cup? I'm not sure if I'm supposed to say that word, but I just did. All right. Welcome, folks from Poland and Bangladesh. Nigeria, welcome. India, Vikas, welcome aboard. All right, without further ado, I'm going to bring in our first guest. She's one of my favorite people at MongoDB. She's written an amazing application that's demonstrating the power of search in your application. Without further ado, Karen Walney, welcome.
Hello.
How are you?
Good. If you were actually doing a competition to find who was farthest, I don't even come close. Everybody's really, really far away from
Right?
From us. That's awesome.
Yeah. It is awesome.
Poland, I actually, in this application, I build a dream team, and I actually have a Polish player on the dream team.
Who's the player? Who's the player from Poland?
Well, I can't actually say his, can't say his name nor spell it, which is one of the reasons I wrote the application. I think everybody I talk to from every different country pronounces it differently. It's the goalie, and his name is, actually, we should have you find the name in the application, Mike. His name is, I think it's Stisney.
Wow, you're brave. Welcome from Canada. All right. Okay, so we're going to be talking about search today, integrating search into your application. It's an absolute necessity. And what a great use case. So there are so many names in soccer today, in football, that I can't even pronounce, let alone figure out how to spell. And man, I want to be able to search for names. I want to gather that information. So what helps us in that space, Karen?
So I actually, I'm sorry, I missed what you just asked because
I'm talking about why search is so important and the value of being able to search for things that you can't quite spell.
So every application needs search, every application that I could think of. And whether you're looking for items in a store, or even like search might be you're looking for something specific, but it might be you're searching for like an idea of something. You need a vacuum cleaner and it has to be of a certain rating. And so even if it's not text, search into your applications can just be looking for something conceptually. And so one of the reasons when we first launched Atlas Search, which was, I think it was 2019, we integrated Lucene into MongoDB. So we're able to write these sort of complex, really fine-grained search capabilities inside applications. I was lucky enough to be able to introduce that. at the MongoDB world stage, but I just kept thinking of all the times where I need search. And so I have this sort of multicultural family, and everybody follows search. And everybody follows soccer, and I'm only a soccer mom, which means that I know everything about soccer. but I like can't spell I can't look them up. I can't do all these things. So I found a data set online, and I thought it'd be kind of cool to as I'm experimenting with Atlas Search, that was the kind of use case I came up with, and it just turned out to be like a lot of fun. So
awesome. It is a great use case. Hey, and so we've got some other special guests in the backstage. You want to bring them on board? Who's back there?
So I actually talk about how much I love search, but I don't know anything about soccer. So I invited some super soccer enthusiasts, semi-pro MongoDB colleagues. Blaine Mincy was one of the first people I met at MongoDB.
Hello, Blaine.
Hi, how's it going?
Good to see you, brother. What's your background in soccer? What's your experience there?
No, I was very blessed. I had the opportunity to do very well in high school. I played Division I university down at Mercer University in Macon, Georgia.
Uh-huh.
And then I had a chance.
And it was soccer for you, not football, right?
It was, well, I always refer to it as proper football.
Okay, there you go.
But that may bother some people. But I see some of the comments saying that it is soccer here in the U.S. But no, I had a chance to play semi-pro, and had a chance to travel around the world a little bit and play. So
yeah,
it's great.
Fantastic. Well, I'm looking forward to hearing your experience around soccer, because I mean, I played as a kid, but that's about the extent of it. Who else do we have backstage? Karen? Oh, there we go.
Hey guys.
Tom, this is Tom Gleitzman. I know all about his soccer career, but Tommy, I'll let you introduce yourself.
Hey, I'm a solutions architect alongside Blaine here at MongoDB, and the majority of my childhood playing soccer revolved around Karen driving me places to play soccer. So,
because I'm his mom. So I'm wearing France jersey. What are we wearing, Mike? You're not wearing a soccer jersey.
I'm not. I'm wearing MongoDB.
Yeah,
you're wearing your other team jersey.
Right now.
I've got the U.S. on.
Sweet.
Unfortunately, we went out in the group stage, but still
I
support.
represent MongoDB colors. So,
what team is that, Tom?
This is Austin FC.
Okay,
so
awesome.
It's,
Great.
Yeah, one of the newer MLS teams.
Yeah, awesome. So, Karen, I know you've got some prepared content, and we want to talk to the folks that are joining the stream about search, the importance of search. I'm going to kind of turn it over to you.
Well, actually, Mike, if you don't mind, I was gonna. What do I have for prepared content? Hold on, let me see. I was gonna put you on the spot, Mike. I kind of wanted to show you some stuff. So let me just share my screen a little bit and show you what I kind of have cooking. So we talked about the soccer use case and why I just kind of like wanted to experiment with this. A lot of it had to deal with like the characters and spelling names. And if you even get if you miss an accent, for instance, then the search wouldn't result. So MongoDB is really great with our B tree index, and I'll talk more about indexes later, but it's really great if you know what you're querying for, if you know your query patterns. But when it comes to sort of natural language and stuff, it's better to use something specialized for search. So that's why we work with Lucene. So this is an example of part of my inspiration of why I built this application. And this is the other inspiration for why I built this application. So so I'm wearing the one with 2 stars. I hopefully will get one with 3 stars. I say this like I'm really into soccer. I'm not. I mean, I'm really into France and I'm really into Mbappe, but he's pretty much the only guy I know. I know Giroud. I know who Giroud is now. I didn't know who he was 2 weeks ago. So we're world champions for at least, I don't know, until this weekend, I suppose. Guys, so this is the application I wrote. What is the schedule for the for that tournament that shall not be named? Like when are the matches being played?
Yeah, the next set of matches are tomorrow and Saturday.
Okay, and for folks watching the replay, today is Thursday, December 8th.
Today's Thursday,
yes,
exactly. Yeah. Yes. Today will be December 8th.
Yep.
But is that when is the final? Is that this weekend?
No, the
No, no,
final's
no.
not this weekend. Yeah, Tom, is it like December 16th or something?
It's in December. I don't know when.
So
I take it a round at a time when it comes to this tournament.
Gotcha. Yeah, me too.
So Tommy
Next
was just
weekend,
home for
Lenny
Next
says.
weekend. There we
Thanksgiving.
go. There
Yeah,
we go.
nice. Thank you, Lenny.
Tommy was just home for Thanksgiving, and that's what he was. And so like I knew everything about it when he was here, and then when he goes back to New York, I don't know anything about it. So anyway, that is. So I wanted to kind of just introduce it that way, but Mike, I wanted to put you on the spot, if you don't
Yeah.
mind.
Mhm.
I'm gonna not share my screen, but
Okay.
I actually gave Mike access to this same data set. So maybe we can, he's never done search before. And I just wanted to, I thought it'd be cool if we could kind of coach you through creating a search index and how you get started with search.
I'd love it. Yeah. So for folks that are wondering what you're looking at right now, I'm showing my screen and I'm logged into MongoDB Atlas, which is our database as a service. It's free to use. I've got a free database instance spun up. This is an M0 class instance. It's free forever. I didn't have to pull out a credit card to spin it up, and it took about 7 minutes or so to actually just launch it. All of the defaults are set. The data, Karen, I'm going to pop up a banner that's pointing to where folks can get links and resources. You've got a GitHub repo with this application in it. Does it include the data?
Yes.
Okay, great. Awesome. So in the comments in the YouTube stream, you should see the links and resources. There's a GitHub repo where you can get access to the data and the application that we're going to be reviewing today. But if you want to play along, it might take you too long to spin up an instance, but maybe follow along and then try this after the fact. This is being recorded, and you're going to be able to come back to the same URL, the same YouTube URL, and get access to this. So if you're watching live, just know that it's recorded. So what I'm going to do now is I'm going to go into my Atlas Search Soccer Stream cluster, and I'm going to check out the collections. And here we've got a soccer database, and we've got a players collection. Okay. So
this collection has about 20,000 players. You can see every player has their own document. And every document has this Oblak. Where is he from, Tom? Well, I guess he plays for Spain, Slovenia. And every document has about 100 different fields on it. So it's quite a heavy document. All sorts of things that I don't know what it means, but you see the player where the country is, with the flag, where the URLs for the flag, for the face, everything like that. So we have numbers in there, we have dates, we have strings, etc., and we can query across all of that once we create a search index. So Mike, I'll let you.
What if I just tried to search? And I can use the filter here. And what if I just tried to search for? I know there's a guy Mbappe that you mentioned earlier. I don't know how to spell his name though. And we don't have the search set up yet, right? It's not set up. This is just the basic query language built into MongoDB. And if I complete this search pattern, I'm finding nothing. So it's clearly I've got his name spelled wrong. So let's keep that in mind. I'm going to reset this, and then we'll go back and we'll do what we need to do to enable Atlas search.
Okay.
So
the first thing you need to do is create a search index.
Okay. So I go to search to do that.
Actually, there's a search indexes. You can go to search, or you can go to that search indexes thing.
Okay. Here we go.
So this is going to create a search index just for this collection. And then click that big green button.
Okay. I'm going to create search index. All right. And okay.
And then
two options.
once you get really, really good at it, you can put in your own JSON documents in this. I have some applications where I actually give the index definitions, and that's where you can do this. But since we're just getting started, we'll do the guided experience of using the visual editor.
Okay.
And then you keep the default name.
Okay.
We'll be on the players database. By the way, this is an outdated, it's a 2022 player database. So if you look up players and they're on the wrong team, sorry about that. So we are on the right collection. We'll go ahead and click next.
Okay.
And actually,
right.
so here's where it gets interesting, where you get all sorts of tunables. We're going to accept all the default indexes, all the default settings, but I'll go ahead and walk you through what this means. So it's telling you what analyzers that we're going to use for this. So the default, when you set your default settings, an analyzer that it uses is the Lucene standard analyzer. So we are using Lucene, the very trusted open source library that's been around for 30 years or so. And we're using the standard Lucene analyzer. But if you were to hit refine your index, you can see that we have lots of different analyzers that you can sort of choose from. White space, symbol, keyword. And I have an example to sort of talk about the differences in those. But if you go down to Lucene language, go back to right where you were. Go back up to,
Okay. Oh, I see. Yeah.
Then, right. And then we have about 40 different languages, English.
Oh, wow. Okay,
all
great.
sorts
And
of
that's
things.
if you know you're storing German, for example, you would use the Lucene German analyzer.
Well, actually, that's a really good case. So one of the big differences between Lucene Standard and Lucene English is that English understands like common stop words, A and the words that come up so often that it sort of dilutes the effectiveness of your search. So it'll remove those. And we'll talk about this is tokenizing. We'll talk about this later, but standard keeps those in. So German recognizes those stop words. And the other thing is that there's some very famous Korean players, I think. I don't know. I definitely don't know how to say their names, and I definitely don't know how to spell them. But this is be like you might want to use a different index on that one too. So you can set that dynamic mapping. Tommy, do you want to talk about what dynamic mapping is and why you might want to use it?
Yeah. So in dynamic mapping is when you want to be able to analyze all of the values within a top level field, as well as all of its embedded fields within it. So in MongoDB, we have a very, very flexible document data model, which means that you could store ultimately JSON documents within documents. So I can have let's say first name, last name, like Kylian Mbappe, and then I could have club, and club could be an embedded subdocument that has the city of the club, the name of the club, and whatnot. If I were to dynamically map club, it would automatically analyze all of the values within that subdocument.
So one of the nice things about dynamic mapping is because lots of times when people use a different solution, when they change their schema or they add a new field, they have to bring down the index and put it back up again, recreate it. This one, if you set dynamic mapping, then it just listens for those changes and indexes new fields automatically. So that's kind of nice.
Yeah,
so
and I guess there's a performance impact on that, right?
Yes, there is. Like one thing is if you're listening for all these changes for fields that you'll never use. So I usually create a very big index while I'm developing, but then when I go into something that I'm sharing or more production, I sort of fine tune it to only the fields that I need the indexes on. So, and then you could add the fields here. You could turn off dynamic and then add the fields individually in here, which I've done. But for this, just to get started, let's go ahead and create the basic index.
Okay, I'm going to save changes.
So here we are back at the beginning, accepted all the default settings.
Okay.
And now he's building this index. Now it says it's going to take a little bit of time, but I think it gets started right away. So why don't we go back to the collections, our data, and let's start searching for players. And so one thing we can set, the way that we have unlocked the search workload using the sort of unified API that MongoDB uses is with aggregations. Blaine, you've been here, I don't know if you've been here longer than Mike, but I'm sure you're better at explaining.
Yeah, just under Mike. I think about a little over 6 years. Mike, how long have you?
Oh,
7 in January.
There you go. Okay.
Yeah. So tell us about aggregations.
Yeah, the aggregation framework is an interesting capability with the query API. If you're coming from relational technology, it's very similar to what you do in a group by statement within SQL, where you're doing your computations, you're doing your calculations, analysis. So the aggregation framework within MongoDB, it allows you to do things in stages. So think in terms of a Linux style pipeline where I have a command and I'm piping the output of one command as the input in another command. But there's a number of different modifiers, one of which is the $search operator that allow you to interface with Atlas Search, the Lucene-based indexes that we're looking at today.
Mm-hmm. Okay, so we're going to build an aggregation. We're going to build stages in our aggregation pipeline. What are we going to start with, Karen?
We always start with search, the dollar search operator, and then you could add other stages onto it first. But I'll talk about this probably a little bit later. But you can see right now, so this is the aggregation pipeline builder inside of Atlas. We have other tools that you can use it, or you can write it out longhand. But I really like this because it gives you an idea that you're on the right track. It'll tell you you get this sort of feedback right away. So we're using the default index. So the first line of every search stage is the default index.
Okay, so I'll just type the name of that default.
Now let's go ahead and look for Mbappe again.
Okay, so I need to remember.
Is this an Mbappe jersey, Tom? I think so.
Yeah, it is. It is. All right. So what do I specify in the query?
I have so many jerseys. I only have one, but so it's MB. Well, I'll let you do. That's the joy of search.
Yeah. Okay. So I'm searching for something that's like Mbappe, and then in the path, this is the field name, right?
Yes, and I believe it's short underscore name.
Okay. All right. So now this is interesting because it's not finding anything, but that is probably because we need another parameter, right?
Yeah.
Fuzzy?
So this option we have is okay. Good. It was indeed short underscore name is fuzzy. So there are lots of options. There are lots of different options you could add to the search stage to allow different things. But one of the reasons why Mbappe didn't show up when Mike did it was because it had an accent on the E. So the fact that we could put these options in it will forgive us for misspelling things or typos or, fat fingers or whatever it is that you have.
Okay, so I want to see the name field.
Okay.
It did
so
find.
Why don't we add another stage then? You want to add another stage for that?
Okay, yeah. How do we clean up what I'm seeing here?
Okay, so I mentioned it has 100 different fields, so I develop a lot and I don't want to deal with all those fields. So I usually add in the project stage now. So we're going to add another stage for a pipeline. As Blaine says, it passes through different stages and transforms our results. So we'll use project. Yep.
All right.
And then here you can say I don't like to have a really bloated payload. So we'll put in, was it short underscore name, :1.
Okay. So a projection is essentially listing the field names and turning them on or off, right?
Mm-hmm. Yes. And so the underscore ID is actually important in MongoDB, and that comes all the time. And if you wanted to remove that, you'd have to explicitly say 0.
Right. Okay. What other fields do we think we want to see in the? Oh, there it is. So there's Mbappe.
There you go. So you have that little accent there.
How do we know how? Well, so Blaine in the private comments asked a good question, like this fuzzy that I added. Tom, yesterday you called out something interesting about this parameter. You want to tell folks about that?
Yeah. So fuzzy matching is a feature that we have within Atlas Search, and you guys just saw the power of what it can do right now. It can actually understand if you've made potential typos within the strings that you're looking for. One of the things that it actually does, though, is you can define how many mistakes that you can make within a misspelling. So it defaults to 2, but you can explicitly define if you only want to allow for 1, if you want to allow for 2, 3, 4, and whatnot.
Interesting. Okay, so when I specify when I explicitly call out max edits of 1, this spelling that I've provided here in the query is still matched.
Correct. And
Yeah.
so when we analyzed k.mbappe, it is one of the things that an analyzer does is it has a character filter within it. It has a tokenizer and it has a token filter.
Mm-hmm.
And so within the token filter, what might have happened is that we might have undercased Mbappe.
Okay.
So now it's case insensitive at this point. If you were to type in uppercase Mbappe with max edits 1, it'll still work.
Oh, interesting. So Mbappe. So it'll still be found. Gotcha. Okay,
so,
great.
Let's change it to max edits 2, just to give us sort of more players that we can. I don't know if we can show. Now we have more players that match. And then let's do one more field inside a project. So this field is not in the original document. So we have to use the meta operator. So we'll call this field score. So actually, yeah, so we'll call the field name should be called score instead of meta. No.
Oh, sorry.
Do you see where you have meta?
I do, yeah. Okay, so that's going to be score.
Mm-hmm. Colon, and then open an object, open curly, and then dollar meta.
Okay.
And then the quotation mark, search score camel case.
Okay.
Okay, so hopefully.
So this is an operator.
And then put a comma underneath that last curly bracket there before the underscore.
Oh,
ID.
right. Yep. Gotcha.
Okay, great.
Oh, that's giving us the search score. Okay, gotcha.
So this search score is plain. I don't know if you've done a lot of if you've done a lot of search work before, but this search score is based on relevance. Do you talk to a lot of people about search? Is that your?
Oh, absolutely. I mean, not only do we talk to a number of customers around just Atlas Search in general, but this capability in terms of a function score is powerful if you're doing a catalog type situation, or like this where we're looking for various footballers around the globe, and most definitely Mbappe. There's only one of him, but we want to make sure we get the right guy. So that 3.4 score, yeah, that's the right guy.
Yeah, we should give him a 3,000. He deserves it. But so the point is that this score that comes back is calculated by Lucy in Atlas Search, and it's going to give every document inside of our collection a score based on relevance, which is basically how well this query matches the documents. So the highest scores get returned to us first. So Mbappe, of course, comes first, and then Mbaye and anybody whose names are similar after that. And this is really important in search because it's the whole reason why your search results come back in the order they are. So if you want to, for your application, you want to surface the best matches to your users first. So that's basically all you need to do to set up a dollar search thing. Actually, there's one more stage that I really like, Mike, for the sake of performance. Just go ahead and add in limit.
Okay.
So I mentioned that we produce that Atlas Search is going to do a grade on every one of the documents. We don't need all the documents. Since we're getting the best matches first, we can just limit to the number we want. Let's go ahead and limit to 10.
Okay.
So this is going to.
Okay. And here on the right is the list of the returned matches and their associated score.
Right.
Yep. And
then you can also inside the Atlas interface. So this is basically the heart of the search engine for this application. And then if you wanted to export the language.
Yeah. Okay. This is powerful right here. So if you're wondering what you're looking at and how you're going to leverage this to write an application to leverage search, boom, here it is. So this is your pipeline. Go ahead and explain it.
So we have our search stage, we have project, we have limit, just those 3 stages. Actually, often I often put limit before project, because that way I don't have to project across all the different fields. It just makes it a tiny bit more performant. But you can export pipeline to lots of different languages. I don't know how many we have in there now, and you could add different
Very cool.
syntax in there, all your include statements and stuff. So for my application, I created these HTTP endpoints that I call from the front end of the application. And so I'll use Node for that. So this is, I built up that. This is what I use for that. So.
Okay. So I'm curious for the folks that are still watching, there's about 30 folks online. What languages are you using? And we can show examples here. So I'm going to guess. I'm going to take a wild guess and say that a lot of people are leveraging Node today. This is what the Node syntax looks like. If you want to leverage Atlas Search, the search index that we just created in MongoDB Atlas Search, we're going to assign a constant to the aggregation pipeline. Yep, Chris is using Node.js. And then we're going to pass in that very same document that we created in the aggregation pipeline builder within Atlas. And you can do the same thing, by the way, in Compass. You can build the aggregation pipeline. We've got a search stage, then we've got a projection stage, and then we've got a limit stage. Great.
So Mike, can you go ahead and share the app from your screen, or do you want me to share from mine?
No, I can.
Okay.
So it doesn't matter. I can do it.
It's atlassearchsoccer.com. And so anybody trying this at home, you can go to this app. It's hosted now. And the whole idea of the app is that you can find different types of soccer players and you could add them to your field. And so this is what I call my dream team. So we have 3 different type of operators. So I was talking earlier that to Amar that the first time I wrote this application years ago, I had Tommy. He had more spare time on his hands, so I suckered him into this before he actually worked here. I suckered him into writing the front end, thinking it was equal to the back end, and I kept breaking the back end for him. Tommy, why don't you coach Mike through that, since you know this app so well? Why don't you coach him?
And before you do, explain to folks what this stack is. This, by the way, is in. I'm going to show the banner real quick. So if you're watching this and you're wondering what we're looking at now, there's a Git repository in the comments below in the description of the video. So check that out. But Tommy, what are we looking at?
Right now, we're looking
Tom.
You get a pass.
Right.
But right now, it's a home page that's going to allow us to be able to search and build out our own dream team. So on the page, we have these 11, I'll call them modals, of empty players. They all say unknown on them. And what we can do is they each represent a position on the field. You click on one of them, and you can just go ahead and click on any of them. And then once you type in the player, it'll provide us with a list of players that we're searching for potentially, and then we can click on one of them, and it'll automatically populate in that position on the screen. And so right now I see that we typed in Mbappe doing the normal text search. And
go ahead and hit the magnifying glass.
Oh,
hit enter.
Okay. There we go.
But so the idea is that as you start typing in different things, then you can sort of see the code being built as you sort of add different things to your search query. So here is that very same code that Mike did, except for doing short name, we did long name. So it's a different field. And then you could see Mbappe there. So if you click on the green heart inside of Mbappe, we should be able to add him to the field.
Oops. I clicked too quickly.
And then we unadded him, but and then if you click, and then once he's added to the field, if you click on him again, you remove him.
Oh, okay. So I moved too quickly. Okay, let's try this again. So here,
one thing that you'll notice here, now that Mike has this up, is that all the players are actually already in sorted order based off of relevance. So a lot of the times, if you run a normal aggregation, you're going to have an extra sort stage that's going to be extra compute, and that's going to take up extra memory on just to perform the sort. We don't actually have to deal with that using the $ search operator.
Messi? I don't do that.
Do Ronaldo. So Ronaldo is interesting. And so because Ronaldo is such a common name, and so you're going to get lots and lots of different results for Ronaldo. And so this again, and so when I was talking about, so you see those red badges at the top right of every player card, that's their relevance-based score. But now that we know the order of the relevance-based score, which has nothing to do with how good the player is, right? So that
Yeah.
overall field that you see on every card, that's kind of the score that FIFA has rated them as a player. So you get the best. So I guess it goes to 100, and the higher number is better. So we can do things now that we have our relevance-based search. We can affect the order in which our players come back using function scoring. So I was thinking that it would be good if we looked for Ronaldo, but we can return it not necessarily in terms of our relevance-based score, but I could have the overall score affect that. So Mike, if you go ahead and hit that function score button at the top.
Here?
Yes. And so now you can see inside the code that I took that score field. Is actually, I used function scoring. We can do different sort of score modifiers, and I'm adding the overall score to the relevance-based score. And now that's the order in which, so now I'm getting the highest rated players first, and we get Ronaldo first.
I missed where does the player's relevance, where is that coming from?
So the relevance on the red badges at the top. So that's now their computed score, their search score. But originally the relevance-based score, go ahead and hit function score again. I don't know actually okay. So that is that red badge is their relevance-based score. Okay. And so remember, we're getting that everything returned with the highest score first. And now I'm going to overwrite that relevance-based score by adding to that relevance-based score that we've seen calculates the overall score.
Okay, and the overall score
I get my best
is coming
players.
from where? Where does that overall number come from? Where does the overall number come from?
FIFA.
Oh, so it's in the data.
It's in the database. Yeah. So this is one way. So for instance, Blaine mentioned earlier that like catalogs and stuff use search a lot. So I imagine one case, Blaine, I don't know, maybe you could chime in, but like one case people could do is if they have a sale this week and they have like, you can say like their sale level is gold or so you can give different items that you want to promote. You can give them a field inside of your documents that's, you could have them 20 or 25 or whatever. And you could, I don't know, Blaine, have you walked somebody through this yet?
Yeah, absolutely. And most recently, I've been using an example that I've been having to do with my kids because we're close to Christmas. And so we're doing a random amount of searching online for things that we don't really understand what they've asked us for, but it goes in hand with this is like talking to customers around product cataloging. And a customer may not know exactly how a product's spelled. A customer may not understand exactly the relevance of the various words that you're putting in your search bar. So this is exactly top of mind. Tom, is there anything that you've seen? I know you built this, so I'm curious, what it took on the back.
He built this one.
Who built this one?
After he built he built the prior one, and then after having worked with me on it, he said, "No way."
He said, "No more."
Yeah, I think that one's still on YouTube too. That was way back in the day, a couple of years ago. But one thing that I will add on is Karen pointed out the function score off to the right. So if you see score with function add on relevance, that's really the computations that are being done below Mike's mouse right here. That's how we have 93.41 as a relevance score for Cristiano Ronaldo. One of the reasons why Cristiano Ronaldo didn't pop up with the immediate 8 that we had before applying the function score was that if you were to look at his full name, you're getting 1, 2, 3, 4, 5 different tokens. And some of them are very long tokens. So when you type in Ronaldo, you're getting a match on Ronaldo, but it's one match out of 5 tokens for this particular document. Whereas the other one was, the first one was like Ronaldo Gonzalez, or I might have butchered that, but it was 2 tokens and they were pretty small. So there you go. Yeah. So that's why he matches immediately with the highest relevance, was because most of the tokens we're actually matching against.
Wow. Fantastic use case. Like, I mean, I can't imagine a better use case for like a retail product catalog where you do have things that you want to be sorted in different order than simply by the
and you don't
name.
have to have So this is a mathematical formula. You could add, you could multiply, you could do like logs and things.
Mhm.
But it could also be something simple, like if you could do just boost on, like a way that you could weight a certain field more is if you do boost and what's the other custom score modifier, Tom? Do you remember?
Not off the top of my head.
The boost thing is critical with the product catalog in case a customer or an organization or a company is trying to have a particular toy they want to always be at the top of the list. They can boost that, based on those various scores. So it's interesting.
Yeah.
Is that like a sponsor?
Constant. It's boost and constant. Those
That's
are the
it.
things.
That's it.
So you can just set it to like 100 and forget it if you wanted to do that, or you could have, if you had different levels, platinum, gold, whatever, then you could sort of have those change. So that's the basic one. But if you want to, we can kind of maybe have Mike find some harder players. Did we add Ronaldo yet? Do you want to add him to your
we did not. Let's do it. So let's go back to the function score. Sort by relevance, and we'll
where
add.
do you want to put him on the? There you go.
I'm going to go back.
Oh, but you put him in Mbappe's spot. That's okay. Let's look for somebody else.
Oh,
Let's do
I did.
this for
I did.
Poland.
Okay. All right.
Should we find Disney?
I'm going to really quickly.
I know we have a couple Polish people in the audience here, so if there's a Polish player that you want us to look up,
drop one in there.
A great call. Let's see if the folks from Poland can give us a suggestion for a player.
Well, I have
maybe
find this Disney guy.
What is his name?
Disney. So yeah, you could try.
No.
Yeah.
France. Oh.
Nope. So let's try a different operator. There's a couple of different operators. Why don't we hit that nifty reset button that took me? I'm very proud of. No, yeah. Okay. I'm very proud of that one. So let's try. That was text. We can try the next operator, which is wildcard.
Okay. So I'm gonna say SCH. Is it like that, like a regular expression?
Yeah. So you can have that. I don't even think you don't even have to have even that much, because now the SCH has to match. I will tell you the S exists. So let's just do S star.
Okay.
And then let's end in Y.
And do I dollar it? Like
now
I would
hit
a
enter.
regex?
Yeah.
Okay.
Oh, where'd it go? Hit it one more time.
You don't dollar it.
You don't dollar it. Okay. No. I'm used to my Perl regular expressions.
Yeah.
There it is.
There he is. Wow.
Well, that was lucky. But you see, okay, so the reason I say it's lucky is because you can see that all those players have the same score of 1. So if you were to do this at home, you might get it in a completely different order, because it's being returned to us with the highest score first, and that just happened to be it. So another way you can do it is, well, he's a goalie. Well, you can put him there. We'll see how he does.
Oh, is that where's the goalie go?
Oh, the very back. Yeah.
This is the bottom?
Very
okay.
Back.
Yeah.
All right, I'm going to put him
back. You can't drag him. That might be the next iteration.
S.
Oops. There's one person in the audience that wants us to look up. I'm going to butcher this name, by the way, but Blaszczykowski. I don't know if I pronounced it.
Oh, yes.
Okay, I can't copy.
That one's also a very good one.
Wow.
And he's also Polish.
Okay.
And so I don't even know how to type that L. So
there's found.
So that L probably counts as a different character. So why don't you just do B?
That.
And then, so why don't we do one thing here? Mike, why don't you hit that advanced scouting button, like all the way to the top left?
Oh, yeah. Okay.
So what this does is, if you scroll down a little bit, now we can show how this is broken up across teams and countries and positions. So we know this guy's Polish.
Mm-hmm.
What position does he play?
So if you scroll up, I can tell you. He plays for Krakow. He plays right midfield for Krakow.
Oh, wait, which one is he?
He's the fourth
Oh,
one.
he's the fourth one. Okay. So, Mike, why don't you do me one more favor? Instead of hitting the green heart, hit that magnifying glass.
Oh, interesting. Okay.
So this is if you want more details about Jakub Laskowski. But the other thing
Blazinskowski.
that I show, so we'll go back to this to that advanced search in a second. But this is some more code here, and you can see that I have also used the more like this functionality. So if I matched inside when I wrote this, is I matched for player traits. You see the scouting report that he has. He's injury prone. It's not very nice to put in your scouting report. He's injury prone, but a good leader, team player. And so I'm looking for other players inside that code who are injury prone, whatever, and that they also play on the same position. So I used, instead of using search, I used the more like this operator to get other players who are like this.
Oh my goodness. Okay, great. So I had no idea that that operator existed.
More like this is fantastic for, Blaine was talking about like catalogs. So if you look up an item, and this brings you items that are like that item.
Oh yeah. Outstanding. So these are some of the things that we see. I mean, I see them when I don't know, I go to Amazon or Best Buy or these retail search catalogs. I see all of these things on the front end. So this is what's happening behind the scenes. Yeah, great.
So let's go back. If you go back to that advanced search one, Blaine, actually, why don't you give Mike something hard to find? So this is what I was telling Mike. Let's play Stump the Chump, and Mike's the chump.
Oh, how dare you? Okay.
So we'll go with one of my. I'm not happy about the team he plays for, but in the World Cup, I'm happy with what he's doing.
Okay.
With the Netherlands, but he's a center back, Virgil van Dijk.
Okay.
Mike, why don't you reset this so we get a clean slate?
Okay.
Go
Thank
to
you.
my nifty reset button.
All right. Great. Okay. So that clears cache, and away we go. I am going to use advanced scouting, and you said he plays center fullback.
Center back. Yeah, right there. Yeah.
Okay.
And then for Netherlands as well.
For Netherlands, okay. Netherlands. There we go. Okay.
So one thing before we hopping into this is that you can see that when we first did Mbappe and Ronaldo, we just had like that basic search query, but now we're adding, every time we click on something, we're adding a new search parameter to our search stage. So you can see the code there. So I have text looking across player positions. I have text looking across countries. So when I start adding these things in together, I can combine them inside the same search stage using that compound operator.
Okay. And it's important to note that these stages are in a filter operator, right?
Well, that's actually a good thing to say as well, Mike. Thank you very much. So we're using that search stage. If you could see inside that big yellow box, we still have $search. It's using compound is the field name now instead, because we're combining things, we use that compound thing. And then the next line, it says must not, should filter. So these are options that you could use. I happen to use filter. I could have used must if I wanted to. Why don't you scroll? Do you see that overall box on to the left of there, or any of those like sliders? Just go ahead and drag that over a little bit. And so now I'm querying across numbers as well, and that happens to be must, and that is just because I felt like it. So how this is going to affect your search results, though, is that must is going to affect it a lot. Should is going to affect it a little bit less, and filter is not going to affect your search result at all. It's either going to include it or exclude it, but it'll all come back with sort of the same score. So if you remove that, slide that overall back over. So now we're just doing this as filters. So if you go ahead and hit search, hit the search button. Yeah. See all of these have no scores. But you did find the player. Is that the player you wanted?
That's him. Yeah.
Which
right
one?
At the top. Okay, this is just lucky.
Yeah.
Well, so one thing you mentioned was filter doesn't impact the search score. It definitely impacts the search result. And so the differences here is we have must and must not. I'm going to group them together. They will search must include what we include within that sub-document within the aggregation, but that'll impact the score. So anything within must, that'll impact the score. Filter operates the same way that a must would, except we're not going to impact the score. So when we have a search like the one that we just gave MongoDB, where we only had a filter clause, then we're not going to have any search score relevance. Yeah.
Gotcha.
Libra Boy is here. Somebody once told me that the people who write these search queries, they're a lot like artists. They kind of have to try different things and see how it helps or doesn't help, if it's better for them or not. Like in this, if we're going to use this soccer analogy, it's a little like you're a coach and you have all these different players that you can deploy in different ways and different combinations. And this is sort of like how you can have these sort of, raw talent and how you want to try and figure it out, maybe play with a few things for the next match, I suppose. I don't know. What do I know about coaching soccer? So.
Outstanding. So what else do people need to know about?
Oh, let's do one more thing. I got one more.
Yeah. Go ahead.
Okay, great. So we talked about, let's reset this.
Okay, here we go.
And let's go back to advanced scouting. So we talked a lot about how you get your results and how you order the results, but sometimes the results aren't there. So I want to kind of circle back to the beginning where we created that index. So Mike, one thing, we can try a couple different things, but let's click on Manchester United in the club. I like to say this is Tommy's favorite team, but it's not his favorite team. I think Tom and Blaine have the same favorite team. So scroll down a little bit more.
Mine is Man United.
Oh, okay.
Mine is Arsenal right above Man United, both in this application and in the actual table.
So Ian's got a good question while we're paused for a second. Are the search components, the checkboxes and the radio buttons that I'm interacting with on the form, are they still using aggregations to return the results?
Yeah. So for instance, you just saw that. So when we were talking about aggregations, we're talking about the dollar search stage as the first stage in the aggregation. These filters, checkboxes, radio buttons. Actually, Mike, why don't you scroll down at the bottom of Manchester United in the club? So you can see the code that results from.
Oh, here we go. Yeah.
So this is like the search building block that I'm contributing to my search stage. So it's still within the aggregation, but it is this thing. So I'm adding a couple of different factors here. I'm combining them in the compound, but that's still within the search stage in my aggregation pipeline.
Okay.
So
this would be dollar search, and then this would be the document we passed.
Yeah. So you can see. So you see this text query Manchester United. Now scroll up a little bit so you can see the entire search code. And so you see that there in the filter. So that's the same code there.
Yep.
So while we're here, do you see underneath that search box, don't press the search box, but I have keyword and I have standard. So toggle that to standard, please.
Okay.
So this is the analyzer that we're using. So this is something that I came up with when I was developing it that I thought was interesting. So if you hit search now, we're looking for players just for Manchester United. So go ahead and hit search. And now you see I have 697 players up there, and they're spread across all of these different, and they're not just Manchester United. They're Manchester City and Manchester whatever. And one of the reasons why that happens is because of that analyzer. Let me, if we change it back to keyword, so change that standard analyzer back to keyword and hit search. And now, now I get it. So if I can maybe take the driving seat just a little bit. Can I share I'll let you control it because I don't want to break anything. Okay, great. So I'm just going to sort of try and wrap up on this thought, I guess. Is we talked about MongoDB and we talked about Atlas Search and we talked about how looking for things was a little bit different. Like you did the filter on Mbappe. When we built Atlas Search with MongoDB, it's actually a different database. And they actually use two different indexes. MongoDB uses a B-tree index, which is fantastic for querying when you know how you're going to query your query patterns. You need something very specific. And Atlas Search uses an inverted index. And I often compare it to like the index that we use in the back of the book. So actually, let me just finish this example real quick. If we had all these different documents, so this is my example, if we had different documents like Manchester United, Manchester, Newcastle United, and Paris Saint-Germain, just because I want them in there. No, they have nothing to do with Manchester or United, but I just have to be in there. If we were to use that, that's our B-tree index, these are typical MongoDB documents. If I were to pass Manchester United and I wanted to analyze this when we created those analyzers, Kami talked about tokens in the beginning, and I wanted to match those documents. If I pass it through the standard Lucene analyzer, it breaks it down into Manchester United. So inside that application, when we're using a standard analyzer, I was matching every team that had Manchester and United inside of it. So my inverted index for search would return Manchester and United, and you can see that it's mapping, Manchester is mapping to documents 1 and 2, Manchester and United is matching to Manchester United and Newcastle United. And that's why all those results showed up. If I were to use keyword, when we change the keyword, that only returns one token, Manchester United. So it doesn't, so if I were to do the same, if I were trying to map it, it would only return results from Manchester United. So this is why the analyzers are really, really important. So when you create your index, we talked about different type of analyzers, but I often, when I kind of coach people through this, I always say I always start with a really big index, but as I sort of try and become more aware of performance and results, etc., I always start with the data whenever I decide what index to use, what analyzer to use inside my index. And I, for a long time, I kind of got what indexes, I thought they were kind of the same thing. So I always think about my data first, how I'm going to query them, how I want my tokens to look like. Like, is somebody going to be free typing into the search box, or are they going to be clicking some boxes? Do I know exactly what they're going to be? So I think about what tokens are going to be, and then I can pick my analyzer. And then my analyzer goes inside. When I create the index, I specify my analyzer and to create that index. And then that index is the first name inside of that search query, the first line.
Makes sense.
That's my millefeuille of Atlas Search. So
fantastic. Awesome. Well, we are coming up on time. Is there anything else we need to share with the audience? Oh, there is a question. What fuzzy options do we have, and how to properly paginate results with Meta? Any of you guys want to take a swing at that one? So the fuzzy options, they'll be in the documentation, right?
There are multiple. And I'm going to preface my answer with, if I'm understanding the question correctly, it is really, what are the options to paginate our search results with MongoDB Atlas? And there are multiple ways that you can do this. The most popular way that I've seen is to, after your search stage, you do a skip and a limit. So I can search over results. Let's say I choose on my application to paginate 20 at a time. And I want to show the third page. I'm going to search. I'm going to skip the first essentially 2 pages worth of results, and I'm only going to limit what I'm showing to the client that's requesting it 20. So skip the first 40, show the last 20 to give me 60, and that's one of the more simple ways to do pagination.
And those skip and limit, those are aggregation pipeline stages, just like search.
And we actually worked with limits when we were building ours out in the first part. So
yeah, fantastic. Yep. Great question, BS. All right.
Actually, and that's what I used for this, but we have like other options, and a lot of it really depends on sort of what your data size is and the different sort of performance impacts for that. But that was a good one.
And what we're searching on too, it's like if we're doing like dates or geospatial, you can use near and filter, and so that might be a better way to search. But yeah,
outstanding. Well, I want to thank you guys for coming on and helping me to understand a little bit more about MongoDB Atlas search. Anything else you want to share with the audience before we wrap up?
We got one more question in, by the way.
Oh, do we?
I think we got a couple in.
Oh, nice. Okay. Let's. Okay, I skipped
Can you
Lenny's. We'll go
remove
back.
documents from the index without re-indexing?
Blaine, you want to tackle that, or?
Do I want to tackle that?
Tackle. I see
I
what you
didn't
did
mean to
there.
put you on the spot.
I actually don't know.
I would think if you can remove them, you'd have to remove them from the collection within MongoDB before it's being indexed. So that's the only way I know to remove a document from the index, because it's always re-indexing as you're adding additional documents to MongoDB. The Lucene-based index is always adding.
So if you don't want, by the way, if you don't want that document in your results, you could also use, remember when I said compound and I said must, and you could use must not. So for instance, inside of the more like this operator, so I looked for the player and I found the players that matched on that, but I also must notted that original player. So if you just wanted to remove that one player from the search results without necessarily removing him without going through the bother removing the index, if that was your end goal, then just put him as a must not.
And you also don't need to explicitly re-index. I'm not sure if I was understanding the question correctly, which is why I punted it off to Blaine. But if you do remove a document, like part of Atlas Search is that we manage the indexing for you. So you remove a document, we'll automatically remove that index from Lucene. Also, conversely, if you were to add a document, we automatically index that in Lucene as well.
All right. So another question: can many search operations get expensive, including fuzzy searches for the database? Can I run them in my replica sets primary, or should I run them on secondaries? It's a great question. I don't think so. You guys can jump in here if you have a better response, but I don't think you would want to direct your indexed queries to a secondary unless you are. Well, that's a great question. I don't know how that works with Atlas Search.
Actually, may I? I do have sort of the life cycle of a query, a slide that builds out that might be able to help Lenny. And you wouldn't. Thank you, Mike.
Mm-hmm.
I wouldn't send it to the secondary. So just to give us an idea of what's going on underneath the hood, is we had mentioned the MongoD and the B tree index and the inverted index. So MongoD has the MongoDB has the MongoD, and then search index uses MongoT. So when the client sends a call, so this example uses maybe Star Wars. When the client sends an aggregation call, search is part of the first stage in the aggregation. It goes to the MongoD. MongoD recognizes the search as the first stage, and it sends it over to MongoT. MongoT will do all of that stuff. It'll do all this stuff inside the search stage. You saw those little clauses and things that we could do. And it's going to get, the only things it gets back is the underscore ID field that we had, and any sort of metadata, like the search score or the highlights or something like that. So it's going to take just the underscore ID and the relevant metadata, and it's going to send that back to MongoD. And then MongoD is going to look up the underscore ID to get those documents, and then it's going to finish the rest of that aggregation before sending it back to the client. So when we think about performance, like it's really valuable to push. Tom had mentioned earlier that there's no need to sort, because like if you were to do a sort stage inside in the aggregation after your search stage, there's no need to sort on the search score because it's already sorted. But then it would have to look up all of those documents, and then it'd have to sort. So it'd just be pulling all this stuff into your working set again, looking up all those things and sorting and adding those stages. So it's probably better to push as much, so don't do like a dollar match later as a stage inside of your aggregation, when you could probably just filter it out inside the search stage. So for performance reasons, it's nice to push as much of that stuff up as possible into your search stage.
Mm-hmm. Wow.
Oh,
I just learned something.
That's a good
What
one.
do we got here? How does search differ if we're going through the Realm GraphQL API?
Well, in many ways, it's the same way. And Nick Raboy, who's on the stream, he and I are doing the same stream next week, I think around the same time, where we actually take the application and we incorporate it with GraphQL. I use more like this with GraphQL, and I also incorporate it with the TikTok API. So now when you look at the players, you can also get their like latest TikTok pop in there. So
That's cool.
Wow. So what's the date and time on that stream?
actually, let me do a little. Do I have the preview here? So I'll just show you a little preview of this.
A little sneak peek, guys.
I use this in my every event. So we're looking up Mbappe.
Mm-hmm.
All right, guys, flinch challenge with the one.
What?
Okay, that's cool.
And so, Karen, what you're saying is that through the GraphQL API, you used a custom resolver to be able to look up Kylian Mbappe off the left, also look up more players like this, and then look up that TikTok through the TikTok API.
All in one call, all in one endpoint call. And so
answer this question, it doesn't really differ at all then.
So so it looks just like that. So the custom resolver is actually just the same search score. This is Richarlison. It's over, the video's over. but but as I was developing this, like all these matches are being on the television upstairs, and I would like go, "Ooh, I wonder what he's trending on TikTok." So that was that. So your search stage is going to look the same, but there's some really interesting things when you do search, and you combine them with. So you do search on your data, and then you could call like external endpoints and combine your. The goal is that I can take GraphQL, I can use these custom resolvers, I can do different things with my data and different things with external data. And with one simplified call, I can really add this sort of interesting, I can make my application into something completely different.
Yeah. I'm excited for that stream. So that's next week, and you're going to be diving into...
Nick, when is that? I don't know when it is. I think it's
all the more reason for you to subscribe to the MongoDB YouTube channel so you don't miss a thing. It'll be listed
next week. It's a week from today, but I think it's an hour earlier. I can't remember if it's an hour earlier, an hour later. But.
All right, so 11 Eastern rather than 12 Eastern.
Yeah.
Awesome. Terrific. Well, we are at an hour and 7, almost 8 minutes. This has been great. I've learned a lot. Yeah. Thank you so much. Guys, anything else you want to share before we wrap up?
Scott,
no, I guess not.
No.
How dare you? How dare you, Scott?
Tommy's he's actually a solution architect. I'm a developer advocate, but I keep recruiting him to help me. Sergey, thank you very much for
thanks everybody.
Thank you very much. And then if you're tweeting at us or anything, like if you want a particular player on the TikTok for next week's stream, let me know. And I'll put them in the demo.
Yeah. And by the way, you can get more great content about MongoDB, about search. You can hear more from Karen and other folks from MongoDB on the MongoDB podcast. It's available at mongodb.com/podcast and wherever you listen to podcasts. It's enough out of me. Thanks, everybody. Have a great day.
Thanks, guys.
Bye. Thank you.
Thank you.